Good morning to all of you. Myself, Professor Bhageshri Lachwani from Ahmedabad Institute of Technology. Today we are here for the subject data structure, that is DS, and in that we will cover a topic that is the operation of stacks. Basically, two operations are the most important for the stack, that is push and pop. Today we will discuss the pop operation. Now, what is actually the pop? Whenever you are trying to pop an item from the stack. That means you are discarding or removing an item from the stack. At that time, the operation used is pop. So, what steps you have to follow? In the pop, very first step is what elements actually you have to take as an input. So, basically, when the function call of pop will be there, two elements you need. First is the S, that is a stack, and second, the top. You see, the most important is here we are not giving an item that we have to remove from the stack. The reason is that in the stack you are only allowed to remove an item that is on the top of the stack. Suppose the stack has three elements. So no need to give an item which you have to discard from the stack because you are only allowed to discard an element 3 that is on the top of the stack. No other will be allowed. The element that is on top of the stack is only allowed to remove from that. Okay. So here as an input parameter, pop function calling have two parameters, that is S, that is the stack on which you are working, and top, that means from where you have to discard the element. The logic is that once where the top is pointed, you will discard that element, you will pop that element from the stack. After removing an item, you will decrement the value of top by 1. Why? Because that element is now empty. You have discarded that element from the stack. That means that position is now blank. So where the pointer currently top will be, it will be always pointed on the stack where our currently top element will be there. So we will first discard the element, then we will decrement the value of the top counter. Okay. So first of all, if we will see the top, basically this function removes and returns the top element from the stack. It is only allowed the top element of the stack that you have to remove. The stack is represented by vector s and it has containing the n number of elements. A pointer top represents the top element in the stack. Now we will see the algorithm. Okay, like in the push operation, we have first discussed whether the condition is overflow or not. Now, the same way, just take an example. I'm giving you an stack, and in the stack, no element will be there. Suppose the stack is already empty, and I'm giving you just pop the item from the stack. But for popping an item, there must be at least one element in the stack, at least, because if the item is not present, how you can remove? So the same logic we will check first. In the push, we have checked for the condition overflow. Here we will check for the condition underflow. Just take an example. What we will check here is the top equals to 0. What it means top equals to 0, that means still no element is there in the stack, no element, because if the top equals to 0, that means it is on the bottom of the stack, because whenever even a single item is filled into the stack, the counter will be top equals to 1, top equals to 2, top equals to 3, and like on. That means still a single element is also not there in the stack. Okay. So first of all, if there is a no element remaining in the stack, that condition is termed as an underflow. What is underflow? That means not even a single item is present into the stack. Okay, so first we will check for the stack underflow. How we will check? If top equals to 0, the top equals to 0 means what? We don't have to do any operation now, just we will give a message to the user that no element is there and underflow condition is there, and you have to return, that means come out of a loop and ending of the program. So then write just stack underflow and return 0. That means you don't have to do any work here. Now, if the stack is not underflow, that means some elements are there in the stack. So what you have to do? First, you have to pop the item and then decrement the top counter by 1. So second step is first decrementing via value. So just top will be top minus 1, so that the first item that we are popping is now not present in the stack. So here our, instead of doing an increment like we have done for the push operation, here we will do the decrement of the operation. That means top will be now top minus 1. And third is return former top element of the stack. That is return. See, this is very important. What element you have to return. Here first we have decremented. Just take an example. In the stack, three values are there. The values are A, B and C, and I'm giving you a task to pop the item. So you will decrement, you will discard the value C because C is on top of the stack. But in the algorithm, in the second step, we have done top equals to top minus 1. That means now top will be on the bth position. Our elements are A, B, C. Previously, top will be pointed on the C. But now we have decremented the top counter. That means now top will be on the bth position. So which element you have to discard or give to the user? That is one above the top. So just read the statement, which is the return statement as of top plus 1, because currently now top is on the bth second element, but we have to return the element that is on the third position that we are removing from the stack. So it will be now pointed with the top plus 1 because already we have decremented the top counter. So return as of top plus 1. So this was about the algorithm. Now we will see with an example. Just see here, as is the stack, and first time we will call three parameters are already there. Okay, minus 5, 8 and 10. So first time function calling will be there. At the time top will be on the 3rd position because initially three elements are there. So first time pop s and top. Okay, that means first pop of the element. So what we will do here, first first step of the algorithm is checked. Top equals to 0, condition is false because our top is equals to 3. So we will go to the second step. Now top will be top minus 1. That means our now top will become 2. And what we have to return, return s of top plus 1. Our top is 2, that means 2 plus 1, that is s of 3. So minus 5 will be discarded. So now top is on the 8th value. Again function calling will be there, pop s of top. So now our top will be on the 2. Check the first step of the algorithm. Top equals to 0. Condition is false. We will go to the second step. So top will be top minus 1. Now our top will become 1. And return top plus 1. That is 1 plus 1. So 8 will be discarded and top will be on the 1th position. Again function calling will be there, pop s of top. So now our top will be on the 1. Again check the first step in the algorithm. If top equals to 0, no, our condition is false because our top is on the 2. So just to go to the second step, top will be top minus 1. Now our top will become 0 and we will discard the item 0 plus 1, that is 10th number. So we will discard the item 10 and top will become 0. Again we will call pop s of top, and now our top is equals to 0. So step 1 we will check, that is top equals to 0, condition is true. So we will just write a message under flow and return 0. So we will come out of the loop. No need to do the step 2 and 3. Okay, this was about the pop operation. That means whenever you are removing an item from the stack, that will be removed from only top of the stack. Three steps you have to follow. First is to check the condition for stack underflow. Second is just decrement the top counter. And third is just pop an item that is on the top of the one. Why top plus 1? Because already we have decremented the counter. That's the reason that we have to do top plus 1. Okay, hope this is clear to all of you. Thank you for watching.